Hey guys, in this lesson we would understand the relationship among pH, pOH and pKw. To understand this relationship we would use the formula Kw is equal to the product of concentration of hydronium ion and hydroxide ion. Then we would take negative log on both sides. So the left side will be negative log of Kw and right side will be negative log of product of hydronium ion and hydroxide ion concentration. Rules of logarithm says that if there is a product of two things, then we can individualize the log by putting a plus sign. So we would be left with plus minus logarithm of hydroxide ion concentration is equal to logarithm of Kw. Now we also know negative log of hydronium ion concentration is equal to pH. Similarly, negative logarithm of hydroxide ion concentration would be equal to pOH, and negative log of Kw would be equal to pKw. So when we apply these three rules to these three terms, we would be finally left with, in place of negative log of Kw, we can put pKw. In case of negative log of H3O positive ion concentration, we would be left with pH, and here we would be left with pOH. We also know one more thing, that hydronium ion concentration and hydroxide ion concentration at 25 degrees Celsius is equal to 10 to the power negative 7 moles per liter. Therefore, at 25 degrees Celsius, if we take negative log of hydronium ion concentration, that would be equal to negative log of 10 to the power negative 7, which when we put on the calculator would give us a 7. And we know negative log of H3O positive is pH. Therefore, pH would be equal to 7 at 25 degrees Celsius. As hydroxide ion concentration is also 10 to the power negative 7 at 25 degrees Celsius, so would be the value of pOH. So the value of pOH would also be 7 at 25 degrees Celsius. Finally, we can conclude that at 25 degrees Celsius, pKw would be equal to 7 plus 7, which is equal to 14. And now we can use this value anywhere else to apply the relationship on any application problem. Let's take the first example. Now we're given a question where the pOH in a given solution is 2.77. If the solution is at 25 degrees Celsius, what is its pH? As we know, at 25 degrees Celsius, pKw is equal to pOH plus pH. And we also know the value of pKw is 14. So we would use this pOH value to sub in place of pOH, and we would isolate for pH. Therefore, we are left with 14 minus 2.77, and that would give us pH equal to 11.23. And this is how we can get pH value when we are given pOH. The temperature has to be 25 degrees Celsius in order to use this relationship, where pKw is equal to 14. Now let's take the second example where the question says a solution is made by dissolving 0.45 moles of NaOH in enough water to make 3.75 liters of solution. Determine the pH and pOH of this solution at 25 degrees Celsius. Whenever we dissolve a solid or a salt in enough water, we're always able to split the solid, or the solid ionizes, giving us Na positive and OH negative aqueous state of ions. Now we are given the moles of sodium hydroxide, which is 0.45, and we are given the volume of solution, which is equal to 3.75 liters. We would use these moles and the volume to find out the concentration of NaOH, and concentration is number of moles over volume in liters. That would be equal to 0.45 divided by 3.75, which is equal to 0.12 moles per liter. Now, since sodium hydroxide is a strong salt that ionizes and its concentration is now known, which is equal to 0.12. As it ionizes completely, the concentration of sodium hydroxide entirely would give us the same concentration of hydroxide ions and sodium ions. Now we can use this concentration of hydroxide ion to find out the value of pOH. We know pOH is negative logarithm of hydroxide ion concentration. All we have to do is just put a negative logarithm of 0.12. That would give us the value of pOH as 0.92. In the question, we are asked to determine pH and pOH. We've already solved for pOH. To find the value of pH, we would use the formula pKw equal to pH plus pOH. As the question is given to us to have a solution at 25 degrees Celsius, we can put in the value of pKw as 14. To find out the pH value, we'll sub in pOH value as 0.92, and we would isolate for pH. That would give us 14 minus 0.92, and that is equal to 13.08. This is how we find out pH when we are given pOH, and the steps that we use to find out pOH are these, where we were given the number of moles of sodium hydroxide and the volume of sodium hydroxide that we use to find out the concentration of sodium hydroxide. From the concentration of sodium hydroxide, we're able to find out the concentration of hydroxide ions. Let's say the next question is, what is the hydronium ion concentration of a solution at 25 degrees Celsius that has a pOH of 7.95? Because we are given the value of pOH and we are looking for hydronium ion concentration, definitely we need to first use pOH to find out pH. Then pH can give us hydronium ion concentration. Because this solution is at 25 degrees Celsius, so we can apply pKw is equal to pH plus pOH formula. pKw is 14. pH is what we are looking for. pOH is given to us as 7.95, and we would isolate for pH. 14 minus 7.95 gives us a pH value of 6.05. Once we get the value of pH, we can find the hydronium ion concentration. As we know, pH is equal to negative logarithm of hydronium ion concentration. pH value is given to us as 6.05. So we have negative logarithm of hydronium ion concentration. We would move this negative on the other side, so this would make this a negative 6.05. In order to solve for inverse of log, always remember inverse of log is an exponential function because this log has no base, so base is 10. All we would have to do is just write down 10 to the power of negative 6.05 would give us hydronium ion concentration, and this gives us the final answer for hydronium ion concentration to be equal to 8.9 times 10 to the power negative 7 moles per liter. And this is how we solve this type of a question where we are given pOH, we use pOH to find out pH, and then we use pH formula to find out the concentration of hydronium ion.